Okay guys, in this grade replacement video, I really don't have, I can use a whiteboard, so I'm gonna use paper. So this is my grade replacement video, and it's for test number 2, and we're gonna do a problem from section 6.1 if I'm not mistaken. Okay, what this problem says is we have to find the maximum area of this parallelogram that's inscribed inside a triangle. We do not know anything other than it's a parallelogram inside a triangle. So what we can do, we know that the area of a parallelogram, any parallelogram, is the height. So we know that this is height. The height times the side. So we know that x times the height. So if we draw another line here, we see that this is a complete rectangle. So if we draw a line here, we know that this is a diagonal. So, and if it's a rectangle, it's a right triangle that has a 90-degree angle, and this is our hypotenuse. So we can use the Pythagorean theorem, which is d squared, which is the diagonal in this case, is equal to h squared plus x squared. So here we're finding the relationship between x and h, and d is a constant here. So if we solve for any of the for any of the variables, I'm going to solve for x. So this would be d squared minus h squared is equal to x squared, and the square root of all of that is the square root of d squared minus h squared is equal to x. So now we have that the area of this rectangle, this triangle, is equal to x, which is the square root of d squared minus h squared, times h. And if we simplify that, we have that a is equal to d squared minus h squared to the 1/2 times h, and we have that. So to find the maximum area of this triangle, we have to find the derivative of a, which is a prime, which is equal to, remember we're finding it in terms of h, so in here we have to use the chain rule and the multiplication rule. So here d is a constant, so it's 0, and we find the derivative of h squared, which is 2h, and we multiply it times 1/2 times the inside squared to the negative 1/2, and we add that to the derivative of this, which is 1 times d squared minus h squared to the 1/2, and this all goes over d squared minus h. Oh, and that's it. Sorry about that. So we have, let's write this on the other paper. So we have that the area prime is 2h to the 1/2 times 1/2 times d squared minus h squared to the negative 1/2 plus d squared minus h squared to the 1/2. So if we simplify this, a prime is equal to negative 2h plus d squared minus h squared to the 1/2 over oh wait, there's a mistake here, sorry about that. It would be a prime is equal to, okay, 2 times negative 2 is 1, so it would be negative h over d squared minus h squared to the 1/2 plus d squared minus h squared to the 1/2. So to simplify this even more, we have that negative h plus, we multiply, the denominator would be this, so we multiply d squared minus h squared times d squared minus h squared, it would be d squared minus h squared. We forget about everything else because negative, if we square this, the exponent would be eliminated. And we put this over the denominator. D squared minus h squared, elevate it to the 1/2. So, to find the maximum area of the rectangle, we have to equalize this to 0. So 0 is equal to negative h plus d squared minus h squared. And this over d squared minus h squared to the 1/2. So this would be eliminated. You multiply this here, and it's 0. So negative h, oh wait, let's just put that h squared, we're putting them in order, minus h plus d squared. So if we solve for h using the quadratic formula, we have negative 1 plus minus the square root of 1 squared of negative negative 1 squared minus 4 times a times c. In this case, it's d squared over 2 times a, which is 1. So if we simplify this, h is equal to negative 1 plus minus the square root of 1 minus 4d squared over 2. So let's write this on the top here. H is equal to negative 1 plus minus the square root of 1 minus 4d squared over 2a. So, since we're working with triangles and geometry, we know that we can't have a negative number. So if negative 1, you subtract another number, it's going to be negative. So we can't have that. So we're going to take the positive number. So h is going to be equal to only negative 1 plus the square root of 1 minus 4d squared over 2. So now we have h. This would be our value, our height for the parallelogram. So now we have to find the length of the base. So we have that x is equal to the square root of d squared minus h squared. So now that we have h, we can substitute. X is equal to the square root of d squared minus, instead of h, we write negative 1 plus the square root of 1 minus 4 d squared over 2 squared. So x would be equal to the square root of d squared minus, we multiply this would be 1 plus 2 square root of 1 minus 4d squared plus 1 minus 4d squared over, to here, over 4. And this would be x is equal to the square root. We find a common denominator, so it would be 4d squared minus 1 plus 1 is 2 plus 2 square root of 1 minus 4d squared minus 4d squared. This goes to here. Over 4. All of this is a square root. So x would be, okay, we have 4d squared minus 4d squared. These are eliminated. And we have that x is equal to the square root of negative 2 plus the square root of 1 minus 4d squared over 4. So this would be our x, and this is our height. So we have our triangle with a parallelogram inscribed, and we have that our height is equal to negative 1 plus the square root of 1 minus 4d squared over 2, and we have that our x is equal to, this was x and this is h, we have that our x is equal to the square root of negative 2 plus 1 minus 4a squared, or 4d squared, over the square root of 4, which is 2. So, now, the area of this parallelogram would be x times h. And we have that x is equal to the square root of negative 2 plus the square root of 1 minus 4d squared over 2 multiplied negative 1 plus the square root of 1 minus d squared over 2. So if we simplify this, we would have that the area would be the square root of negative 2 plus 1 minus 4d squared multiplied times negative 1 plus the square root of 1 minus d squared. All of this over 4. And this would be our answer. You can simplify it even more, but basically this would be our answer, and that's the process. So thank you for your attention. Our next problem is from section 4.19, which is about related rates. So we have a man standing 3 feet from a lamppost casts a shadow 4 feet long. So let's draw that. So we have a lamppost. We don't know the height, so we're just gonna say it's h. And a man is standing 3 feet away. So here is the man. Here's the man, and he is 3 feet away from the lamppost, and he casts a shadow that is 4 feet long. If the man is 6 feet long, 6 feet tall, and walks away from the lamppost, so dx is changing at 400 feet per minute. What rate is the shadow moving? So we're trying to find how dy, let's say this is what, how this is changing, and also how fast is this tip of the shadow moving. So dz. So how can we do this? Well, first, okay, as you can see, this is basically a right triangle, and these two triangles have the same angles. So we can say that we can use proportions to figure this out. So we have that. These are 3 and 4, but let's say this is x and this is y. So we have that y is to 6 as y plus x. So y plus x is to the height. So this would be our proportion. So if we simplify, this would be y times y plus x is equal to, no, yh is equal to 6 times y plus x. And if we substitute our values, we know that x is 3 and y is 4, we would get our height. So y is 4, 4h is equal to 6 times x times 0. X plus y, which would be 3 plus 4, which is 7. So 6 times 7. And this over 2. H is equal to 42 over 4, which is 10.5. So now that we have that, we can get our equation. So we have h. So y over 6 is equal to y plus x over our height, which is 10.5. So if we simplify this, this would be 10.5 y is equal to 6 times y plus x. So we divide by So we simplified 10.5. Y is equal to, right, let's do it. And if we divide by 6, we have that 10.5 over 6. Okay, we have 1.75 is y, and 6 is equal to y plus x. And 0.75 is equal to x. We know that 0.75 is 3/4, y is equal to x. So we have that y is equal to 4/3 of x. So do this right here. Y is equal to 4/3 of x. If we derive this, we can get that dy of dt is equal to 4/3 of dx times dt. So we already have dx, so we can get dy. So dy over dt is equal to 4/3 times 400 feet per minute. And this is dy over dt is equal to 1600 over 3 feet per minute. And this is how fast the shadow is moving. So, how can we get how fast the tip of the shadow is moving? Basically, it's how fast everything here, this base, how fast it's moving. So, we have that this base, we can assign it z. We know that x plus y is our base, so we can say that z is equal to x plus y. So, if we derive this equation, we have that dz over dt is equal to dx over dt plus dy over dt. And we already have dt, dx, and we already have dy, so we can substitute. So, dz over dt is equal to dx, which is 400 feet per minute, plus dy, which is 1600 over 3 feet per minute. And when we sum this, we have that dz over dt, where the common denominator is 3, so 400 times 3 is 1200. 1200 plus 1600 over 3 feet per minute. And dz over dt is equal to 2800 over 3 feet per minute. And this is our dz. So, through our process, we figured out, we had this, we figured out what dy was, which is 1600 over 3 feet per minute, and we also figured out how fast the tip of the shadow was moving, which was 2800 over 3 feet per minute.